Hello children, in today's session we will be discussing the refraction of light through a prism. Children, in a previous class we discussed the refraction of light through a glass slab. So at the end of this session you will come to know that what is the difference between refraction of light through a glass slab and refraction of light through a prism. So children, especially in this session we will be learning. So first we will see how to calculate the refractive index of a given prism. It's very important. And after that we will be discussing the angle of deviation and on which factors does the angle of deviation depend. Children, first of all, what is a prism? So it's a very important to understand here. What is a prism? Children, a 3D picture of the prism seems to be like this. So this is how actually prism looks. But how can we define what is the prism? So how the refraction can take place here? So first let us learn what actually prism is. Children, here regarding prism here, we need to remember two very important things. What is that here? The transparent, very important word it is. Transparent and refracting medium. Transparent and refracting medium. 5 plane surfaces. Children, just have a look here. Let us take here, children. So here is 2 surfaces. Let us take like this. Let us make some, fine. Now here is, you can see that here is one surface, plane surface, and here is one more plane surface. It's clear. It's one plane surface and here is one more plane surface. And here bottom one more surface will be there. So here 1, 2 and 3 plane surfaces. And this side it is closed. One closed end, front one, fourth one, and here fifth one is this end. So total 1, 2, 3, 4, 5. So this is how actually they are arranged so that it looks from front view. How is it looking, children? So it is looking like a triangle. So here what is a prism here? Prism is a transparent, refracting, and even you can add homogeneous medium which is consisting of 5 plane surfaces inclined, so that what happens here, looking this front view is looking like a triangle. This is what. Now let us see some basic terms related to the prism. Children, here if you can see in this actually here you can, so here is there is an angle, right? There is an angle, which means what? So there is some angle between 2 refracting surfaces. So children, here if you again let us consider this one. So here is one side and the second side, children. So these 2 surfaces are called refracting surfaces. So in a picture you can see that here it is A, B, E, D is one surface and it is A, C, F, D. Children, look very important. So it is A, B, E, D and one more surface is ACFD. These 2 are called refracting surfaces. And if you can see, children, these 2 refracting surfaces they are inclined at a certain angle. Just look at here. This is one refracting surface. Here is one more refracting surface. Now these 2 are inclined at an angle. This angle is called angle of the prism. So what is angle of the prism here? The angle between 2 refracting surfaces. So in this figure it can be here angle BAC is called angle of the prism. It is called angle of the prism. Children, for a equilateral triangle, usually it is a 60 degrees. For equilateral triangle, the angle of the prism is 60 degrees. Now look at here BECF. So if these 2 are the refracting surfaces, so this is BCEF. This is called base of the prism. Usually it is a rough. It will be having more thickness. It is a bit rough only. So here BCFE is called base of the prism. This is called actually base of the prism. It is called actually, it is a base of the prism. Now dear children, here AD in the figure, AD is called, it is a refracting edge. It is called refracting edge. Refracting edge. Children, let us just, you have to understand how actually prism look. It's very, very important. As I said that, children, here two surfaces here, third surface is the base and these two closed one. There are two, total 5 surfaces. These two surfaces are called refracting surfaces. The angle between these two refracting surfaces is called angle of the prism. And here this is called base of the prism. And children, this one is there, this edge which is connecting two refracting surfaces is called refracting edge. But children, whenever we are discussing and whenever we are making a diagram and discussing for the calculation of refractive index or to show refraction through the prism, every time we don't take a 3-dimensional diagram, rather we can take a principal section of the prism. So what is this principal section of the prism is very important. Children, for suppose here is a marker, cylindrical shape it is. So if you can make it into slices, just imagine it is a carrot. If you want to make a carrot into slices, check something like this. What type of, what we can say slices you will get, children? You will get a circular one, you will get actually a circular one. In the same manner, just you take this prism, okay, just imagine that we are making into slices perpendicular to this refracting edge. Perpendicular to refracting edge. Then what type of, what we get plane surfaces you will get? Triangular shape will get. That triangular shape one only we can, the slice which is in the form of triangular surface, triangular shape is called what is it? Principal section of the prism. Means like this, one ABC you can take out, one ABC like this. Just means we are making the slices, we are taking out the surfaces perpendicular to the edge, refracting edge of the prism. So here in this figure, here it is ABC is called principal section of the prism. This is called principal section of the prism. Now, as I said that, so in order to understand, in order to discuss the concept of prism and everything, every time we will consider principal section only. Instead of taking a 3-dimensional picture, we will be taking, every time we will be taking a principal section of the prism only, so that we can understand easy way, so that the concept and the discussion will become more simple. Otherwise with the 3-dimensional also we can take, but the thing is that when we are making an angle, there will be a little bit confusion. Otherwise nothing is wrong in taking 3D figure, or this principal section is nothing but what, it is a 2-dimensional figure of what? It is a prism. Okay, fine. So these are the basic terms. Children, once again, what is prism here? What is a prism? Prism is a transparent refracting homogeneous medium which is consisting of 5 plane surfaces arranged in the form of triangle. They are inclined in the form of actually triangle. Now we will see how refraction will takes place. So children, as I said that, in order to discuss the refraction through the prism, we will consider only principal section of the prism. In the simple terms, 2-dimensional figure of prism we will consider. For suppose, children, look at it. Let us consider the principal section. Children, ABC is what? Principal section of the prism, such a way that this angle is called angle of the prism. AC are called refracting surfaces, and the BC is called what we can say base of the prism. Now dear children, we will see how refraction will take place when monochromatic light incidents on one of the refracting surface of the prism. Then what is this so called monochromatic light? Children, mono means single, chrome means color. So light with single color, is called monochromatic light. Means it might be red color, it might be green color, it might be blue color. Then what happens when we take a polychromatic light, that is white light if we can take. So that we will be discussing in what we can say in a spectrum topic, we will be discussing what happens when white light falls on the prism. But today complete discussion with monochromatic light only. Children, here let us consider here is one, so this is incident light, let us name it as a PQ, it is P, so at this point it is incidenting Q. So at AB means on this AB refracting surface, PQ incident ray is incidenting, and here is, let us make here is a normal drawn to this, such a way that children, this will be the angle between incident ray and a normal is called angle of incidence. Let us say I. Now what happens at this point QD, children? As the light is moving from rarer to denser medium, that is air to glass, rare to denser, already we discussed. So when light travels from rarer to denser medium, what would happen? It can travel, it can bend towards the normal. So dear children, if there was no prism, what would happen? This light would have traveled along like this. So this is the virginal path of the light ray. If there was no prism, light would have traveled along a straight line path. But as a prism is present, there is a change in medium, and moreover, it is not a normal incidence. Then what happens? Light ray moves towards the normal. So this is how actually light ray moves towards the normal. So here QR, let us say this point is R. QR is a refracted ray. Dear children, it is not compulsory that refracted rays should be parallel to the base of the prism. It is not compulsory. Only in a minimum deviation condition only, refracted ray which is passing through the prism is parallel to the base of the prism. So regarding that, what is what we can say minimum deviation, angle of minimum deviation. So after this, we will be discussing about that. Okay. So again, I am saying it is not compulsory that refracted ray should be parallel to the principal axis. It is not compulsory. Okay, fine. Now, so as long as it is passing through the prism, dear children, as the medium is same, it can travel in a straight line path. But at this point called R, what is happening? Light is moving from denser to rarer, that is glass to air, that is denser to rarer. So whenever light moves from denser to rarer, what happens? It speeds up, due to which it moves away from the normal. So here also, dear children, let us make a normal. So that what happens? Light moves, let us say it is a point R. So light moves away from the normal. So let us name it as RS. Here is a RS. Children, PQ is a incident ray, QR is a refracted ray, RS is what? Emergent ray. Such a way that the angle between normal drawn and emergent ray is called emergent, angle of emergence. It is called angle of emergence. Children, the angle between incident ray and normal is called angle of incidence, whereas the angle between emergent ray and normal is called angle of emergence. Angle of emergence. Now, dear children, look at here. Then what is this here? This is the angle between normal and refracted ray at a first surface. So it is taken as first angle of refraction, whereas this is the angle between normal and it is a refracted ray. So it is a angle of refraction at second refracting surface. Second refracting surface. Now what we do is that, children, let us try to connect these two rays so that here will be an angle. Let us say this angle is T. It is an unknown angle. It is an unknown angle. And children, here one more very important thing, if you can notice here, then what will be this angle, dear children? What will be this angle? Look at here. This is white. Not writing. So here is, yeah, what is this angle, dear children? So opposite angle must be equal, means this total must be I only. From this R1 is left. Then what is this one? So it will be I minus R1. It will be I minus R1. Just let us try to extend this slider backward. Children, here, see, emergent ray we are extending backward. Try to understand. Emergent ray we are extending backward, so that they will meet at this point D. At this point D. And the children, when emergent ray extended backward, what is happening? It is making an angle. It is making some angle. This angle we can call it as a angle of deviation. So it's very important. What is angle of deviation and on which factor does it depend? Then we will be discussing afterwards. Look at here. So this is the angle, means how we are getting that angle of deviation? Emergent ray is extended backward, so that there will be some angle between the virginal path of the ray and emergent ray when extended backward. That angle only we can call it as a angle of deviation. But dear children, as I said that this is a point is a D, then what will be this angle here? Look at here. So already it is a delta. So this angle is how much? This angle is how much? It's very important. Children, look at here. This total is 180. 180. From that 180, delta is gone. So this will be 180 minus delta. 180 minus delta is that angle D is a 180 minus delta. Then what about this D, children? This angle would be, so this is going to be E minus R2. E minus R2 it is. E minus R2. Okay, children. See, try to understand here, children. So, this is the first angle of refraction. R2 is the second angle of refraction. And as R1 is gone from this, see, opposite angles must be equal. And this is I. So, this total must be I. From that R1 is gone. So, that this angle is equal to I minus R1. And the same way, this is R2. So, that this is E minus R2. And here one very important thing is that here what we are doing here, we are extending the, here means we are prolonging, we are extending this emergent ray backwards so that it is making some angle with the virginal path of the ray. That only we can call it as a angle of deviation. As it is an angle of deviation, children. So this angle is how much here? 180 minus delta. Now, dear children, here what are we going to do? So here let us take here from this triangle, dear children. So let us take a triangle QTR. Children, try to understand. This is QTR. This triangle we are taking. This triangle. So from the triangle QTR, we can write R1 plus T plus R2 is equal to 180 degrees. Let it be the first equation. Okay, fine. And at the same time here, look at here. It's a AQTR. It's a quadrant. So the sum of the angles of that quadrant is equal to 360 degrees. So let us take a quadrant here. AQTR. From this we can write angle A plus angle Q plus angle T is a T plus angle R is equal to 360 degrees. But it is a very important thing. What we have to understand is that here, if you can look at here, what is this angle QD, children? Angle Q is nothing but, it is 90 degrees. Angle Q is nothing but here 90 degrees. And even angle R also, it's the normal, right? So it is also 90 degrees only. So now let us substitute that here. So here it is angle A plus 90 degrees plus T plus here. Again, it is a angle R is 90 degrees only from the picture, it is 360 degrees. So, children, 90 plus 90 is 180. When 180 is taken to this side, 360 minus 180. So, it is going to be again 180 only. So, here we got angle A plus T is equal to 180 degrees. So, let it be the equation 2. Now, dear children, from equation 1 and 2, if you can see, as RHS are equal, LHS to be equated, then you may get one doubt. So, why we need to equate here? Children, here T is what here? Unknown angle. That must be eliminated first. That must be eliminated. So, from 1 and 2, what do we get here? Angle A plus T is equal to R1 plus T plus R2. Sorry, it's A, right? So, we should not do this. T gets cancelled. So, here we got angle A is equal to, here it is R1 plus R2. Children, this is a very important. It's one of the conclusions here. Very important. Means here it is angle of the prism is always equal to the sum of the angle of refractions. I repeat once again here. So, here the angle of prism is always equal to the sum of this angle of the refraction. So, A is equal to R1 plus R2. It's a very important conclusion. Now, dear children, next let us consider here triangle. So, let it be equation 3. This we got equation 3. Now, from dear children, from the figure triangle, let us consider QDR. This triangle now, children, try to understand this triangle. This triangle we are considering this QD, this one QDR. This triangle we are considering. From that QDR, what can we write? The sum of these three angles, that is I minus R1 plus E minus R2 plus 180 minus delta. The sum of these three angles is equal to the 180 degrees. Look at here. So, what can we write here? I minus R1 plus 180 minus delta plus E minus R2 is equal to 180 degrees. is equal to the 180 degrees, children. So here 180 cancel. So this can we write like this, I minus of, here R1 is there, here R2 is there, we are taking a minus as a common. So minus of R1 plus R2 minus delta, so what can we make more here, plus E is equal to 0. Now dear children, this minus delta and minus R1 plus R2, let us take a right side so that they will become positive. So it will be I plus E is equal to delta plus, what we can say, yes. Children, here R1 plus R2 is what here? R1 plus R2 is nothing but A here. So in the place of R1 plus R2, let us substitute it is A. So what will happen? It is a A. Children, it is one more very important conclusion. That is, the sum of the angle of incidence and angle of emergence is equal to the sum of the angle of the prism and angle of the deviation. So these two are the very important conclusions. I repeat once again, teacher. So what are the two important conclusions which we got so far here? Angle of the prism is equal to the sum of the angle of refractions. The second conclusion is that here angle of incidence plus angle of emergence is equal to the sum of the angle of deviation and angle of the prism. Okay, first you copy it, then we will proceed and we will see how to calculate the refractive index of this given prism. Just copy it. So the first equation which we got, A is equal to R1 plus R2. Let it make as a first equation. The second equation, whatever we got here, the sum of the angle of incidence and angle of emergence is equal to sum of the angle of deviation plus angle of the prism. Two equations, children. Now teacher, at a minimum deviation, it's very important. This is a word called minimum deviation, very important, teacher. So in a minimum deviation position to the base of the prism, that is to base, let us say directly it's a base. So what happens, dear children, when angle of refraction is, it's a refracted ray, is a parallel to the base of the prism, means look at here. So here is this one. So light ray is going like this, so parallel to this and this one. So it is the angle of incidence and here angle of emergence. So refracted ray is parallel. If refracted ray is parallel to the base of the prism, dear children, what will happen? Angle of incidence equal to the angle of emergence. At the same time, these two angle of refractions also will be same. That is here R1 is equal to R2. This is very important. Dear children, in a minimum deviation condition, angle of incidence equal to angle of emergence and two angle of refractions are same. So these two R1 R2 is equal, we can equate to R. Now from first equation, dear children, here from first equation, what can we write here? A is equal to R plus R. That is here A is equal to 2R, which implies R is equal to A by 2. R is equal to A by 2. It is one more important conclusion. So here in a minimum deviation condition, dear children, angle of refraction is equal to the half of the angle of the prism. Now from 2, what can we make here? From 2 here we can make, so as I is equal to E, so in the place of E we can substitute I only. That is here I plus I is equal to delta minimum. So it is the minimum deviation condition. So we will discuss what actually deviation and minimum deviations will be discussing. So here till that time just let us follow here. So it is the angle of the prism. Now I plus I will be 2I. It is 2I is equal to delta minimum plus A. From this, dear children, what can we write here? I is equal to delta minimum plus A by 2. That is in a minimum deviation condition. The angle of incidence or angle of emergence is always equal to the half of the sum of the angle of deviation and angle of the prism. It's a very important conclusions. Now dear children, by using this only, we are going to consider the refractive index of the prism, dear children. So here what we do is that let mu2 is a refractive index of the prism and mu1 be the medium in which prism is placed. Of course, here it is air. So its value is 1 only. so that you can take mu2 as a mu only, because when two refractive index are there, you can take a mu1, mu2. Anyhow here refractive index of the air is 1 only. So let us consider refractive index of the prism as a mu. So now dear children, what we have to do, let us recall once again Snell's law. Children, what is the Snell's law here? The refractive index of second medium with respect to first medium is equal to the ratio of sine of angle of incidence to the sine of angle of refraction. That is what we are going to apply. Means now we are going to apply the Snell's law at AB refracting surface. We are going to apply Snell's law at AB refracting surface. Okay. Children, can you rub this? Okay, fine. Now let us apply the Snell's law. Let us apply the Snell's law at refracting surface. Where? First refracting surface. So here apply here Snell's law at AB refracting surface. AB refracting surface. So children, in which medium the refractive index of the medium in which refraction is taking place? That is what second medium is, this one. So we can write like this: mu2 by mu1 is equal to sine of angle of incidence by sine of angle of refraction. Anyhow, mu2 is equal to this mu only, mu by 1. Anyhow, 1 means it simply is, we can write it as a mu only. That is mu is equal to, we can write mu is equal to sine I is equal to, we got how much it is? It will be delta m plus a by 2 by sine r is equal to how much? It is a by 2. It is a by 2. So children, this is the formula to calculate the very important calculation which we got. This is what is, children? It is the formula to calculate the refractive index of the given prism. Means by knowing the a value, by knowing the delta m value, so definitely what we can happen, we can calculate the refractive index of a given prism. But dear children, whatever we discussed here, this whatever we have taken the prism, it is thick prism it is. Then what will happen when we consider the thin prism? Then you make it a one doubt first of all here. What is thin prism? Very important children. It's very important. What is a thin prism? Means children, the prism in which the angle of prism is equal to the 4 degrees. Very simple it is. Means they are very close. Means seems to be like a, I can say thick glass slab, little bit more or less it is like. Means these two angle of refractions are very less. Means the angle between the two refracting surface should be equal to 4 degrees or less than that. Such a prism is called thin prism. But for thin prism, dear children, how this expression will be modified? Look at here, dear children. For a very thin prisms, dear children, what will happen? This angle will be very small. This angle will be very small. That is, A is small, very small. Then dear children, here what will happen is, very important thing is, in a trigonometry we will get a one point. What is that? If theta is small, if theta is very small, then sin theta can be considered as a theta only. If theta is small, sin theta is a negligible. So directly we can take sin theta as a theta only. According to that here, what can we write this one here? Mu is equal to, so sin delta m plus a by 2, we can take directly it is a delta m plus a by 2 by, we can take directly it is a by 2 only. So 2 cancel each children. Get this a this side, so it is a multiplied. So here what do we get here? Mu a is equal to delta m plus a, So get this a this side, so it is delta m is equal to mu a minus a. So from this we can take a as a common. So it is delta m is equal to, the children, a into mu minus 1. So it is one more important conclusion. But this is only for what, children? It is only for thin prism only. So it's very important. So whatever the expression which we derived is for thick prism. In the case of thin prism, dear children, the angle A is very small. Means it is almost approximately equal to the 4 degrees or less than 4 degrees. In that case, what will happen here? Sin theta can be considered as a theta only. So in the place of sin delta m plus a by 2, we have taken only delta m plus a by 2 by a by 2. 2 gets cancelled. Get this a this side, so that mu a is equal to delta m plus a. get this A this side, so that it will be delta M is equal to mu A minus A. From this we can take A as a common. So delta M is equal to A into mu minus 1. So from this, of course, we can make a one conclusion. So this angle of deviation, minimum deviation, depending on here A, that is angle of the prism, and the mu is what here? Refractive index of the prism. So dear children, this is how actually refraction means light will undergo refraction through a prism. It's very, very important. Now dear children, before going to discuss what actual angle of deviation and on which factor does it depend, let us discuss very, very important thing is that what is the difference between, means when light passes through the prism, refraction is taking place. At the same time, when light passes through the glass slab also, refraction is taking place. But what makes a difference? Very important. Look at here. Children, in the case of glass slab, this is what we got actually. So when light falls like this, what happens? Here we have taken a normal, it will move towards the normal, and this will be the virginal path of the ray. And at this point, what happened? So it will go like this, so that it is angle of incidence and here is angle of emergence. But whereas in the case of the prism, what had happened? Look at here. When light incidents like this is the normal, such a way that it is angle of incidence. Here it is getting refracted, and here is one more normal. Finally, light will emerge out, so that it is an angle of emergence. Still, the main difference, so when refraction takes place through prism and the glass slab, the one very, very important point what we have to notice is that, dear children, here whenever light passes through the prism, dear children, here what is happening? There is no deviation, means here deviation produces 0. Very, very important. The deviation produced with means angle of incidence is always equal to the angle of emergence. So here glass slab does not produce deviation. But whereas in the case of prism, if you can notice, dear children, here actually light would have traveled like this. So it is getting deviated. Means this is the angle of deviation at the first refracting surface. The second refracting surface, again light would have traveled like this, but it is going like this. So here light is getting deviated, twice it is getting. Of course, how can we calculate total deviation? Total deviation is equal to delta 1 plus delta 2, we can calculate the total deviation. So here what we have to notice that here at the first refracting surface, refracted ray is bending towards the base of the prism. At the second refracting surface also, light is bending towards the prism only, means there is a deviation. So the main difference is that glass slab does not produce a deviation in incident ray, but whereas prism will produce a deviation. That too, twice deviation, means the light ray which is getting deviated is moving towards the base of the prism. So here there is no deviation, but here there is a deviation. So this is the difference between the refraction through glass slab and refraction through a prism. Now the very important thing is that angle of deviation. What is angle of deviation and which factor does it depend? Very important. So for that, dear children, let us consider once again principal section of the prism. This is principal section of the prism. Now we are not going to consider all the angles here. So it is A, we are not going to consider, only simple, very simple picture we will take. Children, here is incident ray, so normal drawn, so that light gets refracted like this, and again here is a normal drawn, so finally it will go like this. Okay, it is fine. Now dear children, if there is no prism here, this light would have traveled like this, right? So this what? Virginal path of the ray, light would have traveled like this. And here is emergent ray, let us name it as a PQ is incident ray, QR refracted ray, RS is emergent ray. Now this RS ray backwards. When we extend emergent ray backward, dear children, so this emergent ray is making some angle. Emergent ray is making some angle. This angle only we can call it as a angle of deviation. This only we can call it as angle of deviation. So how to define angle of deviation? Very important. Very much important, children. So here, what is happening actually? Light ray would have traveled like this, but it is getting deviated through certain angle. That angle is called angle of deviation. Which means what? The angle through which incident ray gets deviated from its original path is called angle of deviation. Let us write here. Light would have traveled along a straight line path. Due to the presence of prism, through certain angle it is getting deviated. That angle only we can call it as the angle of deviation. Now on which factor does the angle of deviation produced by any prism depends? So mainly depends on 4 factors. Let us see, very important. The first factor is that angle of deviation depends on the angle of the prism. First one it is angle of the prism. Now how does it depend? Let us take a small diagram to understand this. For suppose here is prism which is taken. So this is how actually refraction is happening. Okay. Now let us prolong this light ray. So this will be the angle of deviation. And let us take one more prism like this, dear children. But the condition is that both are made up of the same material. So here light is incident like this. If there was no prism, light would have traveled like this. And this is how light gets refracted. Finally it will come out. Now extend backward. So this is delta 1 and look at it, this will be delta 2. So you can notice that, dear children, here delta 2 is greater than delta 1. Here delta 2 is greater than delta 1. What is the reason? Just notice that here angle of the prism is small, here angle of prism is more. So since let us say this is the angle of prism is A1 and here angle of prism is A2. Since A2 is greater than A1. So what can we notice here? We can notice that here more the angle of the prism, more the angle of deviation for a given material. So we can make a conclusion that angle of deviation is proportional to the angle of the prism. So it's very important conclusion. Means for thick prisms deviation is more, for thin prisms deviation is less. Which means what here? Here angle of deviation is proportional to the angle of the prism. This is the first factor on which angle of deviation depends. Now here look at here second case. Second case is a refractive index. Second case edition is a refractive index. So here how does this angle of deviation depends? Angle depends on the the refractive index. So children, before that, let us take one example here. It is a prism. So here prism, look at here. Okay, and it is made up of with flint glass, let us say, and it is made up of with a crown glass. Now such that the angle of the prism is same, but what makes the difference? The material with which they made is different. As the material is different, obviously there is a change in the refractive index. So it's a very important point thing is that here we know that here refractive index of the flint glass is more than that of the crown glass. Very important. Very important. And let us say delta 1 is the deviation produced by the prism made up of the flint, whereas delta 2 is the deviation produced by the prism made up of the crown glass. Then what do we notice? We notice is that here we notice that delta 1 is greater than delta 2. Delta 1 is greater than delta 2. Why? Because the refractive index of the flint glass is more than that of the crown glass. So which means what? More the refractive index, more the deviation. Less the refractive index, less the deviation. So hence we can say that here angle of deviation is proportional to the refractive index of the material with which prism is made. Children, here so far we discussed 2 factors. One is what? Angle of deviation is depending on angle of prism. How? Proportional to, and here even angle of deviation is proportional to the refractive index also. Just copy it. Now the third factor, first factor is angle of the prism and the second factor is refractive index of the material of the prism with which it is made, and the third one is that children is a what we can say is a wavelength, color. It is color or wavelength of light used. It is wavelength of light. It is lambda. So experimentally it is noticed that angle of deviation is inversely proportional to the lambda. angle of deviation is inversely proportional to the lambda, which means what? More the wavelength, less the deviation. Less the wavelength, more the deviation. Dear children, here through a same prism, red color and violet color, both are passing, both are getting refracted. Which color will get deviated more? Which color? Children, just you think. Red color and violet color, both are going, means both are getting refracted. So, which color will get deviated most? Children, it is undoubtedly it is a violet color. Why? See, it is refractive. What we can say is the angle of deviation is inversely proportional to the wavelength. Children, we know that wavelength of red color is greater than the wavelength of violet color. So, as the wavelength is more for red color, deviation is less. So, here deviation of red color is less than that of the deviation of violet color. So, here hence deviation, angle of deviation is inversely proportional to the wavelength. So, more the wavelength, less the deviation, less the wavelength, more the deviation. And the fourth factor, dear children, fourth one is a very much important. Means so far we discussed three factors. One is angle of the prism, second one is refractive index, and third one is color. Dear children, out of these three, either one is proportional or another one is what, dear children? Inversely proportional. But next factor, whatever we are going to discuss, it is neither proportional nor inversely proportional. Means what? There won't be any correct linear relationship. That is what? Angle of deviation. So, children, the very important is that the fourth one is angle of deviation. Very important. Angle of deviation. So, children, here we are going to get a graph which is also examination point of view very much important. So, let us see how angle of deviation is depending on the angle of what we get the incidence. For that, children, let us take a small example here. Let us take, children, experimentally, let us take here is the angle of incidence and here is angle of deviation. For suppose, just example I am taking here. So, let us take here is 30 degrees, 35 degrees, 40 degrees, let us take 45 degrees, 50 degrees, some 55 and is 60. So, how many? 1, 2, 3, 4, 5, 6, 7. Okay. Which means for every, for angle of incidence, definitely what will happen? There will be a particular value of angle of deviation. So, it is noticed that, children, it is just example, not exactly it is. So, for suppose for this I is equal to 30 degrees, okay, corresponding value of the angle of deviation, it might be, for example, 34 degrees, okay. For 35 degrees, it might be 31 degrees. For 40 degrees, it might be 30 degrees. For 45 degrees, it might be from 28 degrees. For 50 degrees, it might be some 32 degrees. For 55, just it might be 37 degrees. For 60 degrees, it might be like a 37 degrees. Dear children, in this example, let us just observe, let us notice what is happening. Here, angle of incidence is increasing, no doubt about it. But what about angle of deviation? Can we say that angle of deviation is increasing? No. Or else can we say that angle of deviation is decreasing? No, we can't say that. Why? Look at here. From here, 34 to 28. What is happening here? Angle of deviation is decreasing. As you go on increasing the angle of incidence, angle of deviation is decreasing. But whereas again from here to here, what is happening? Angle of deviation is increasing. This is a specialty. But if you can notice, so there is some special value. Look at here. There is some special value of angle of incidence where angle of deviation is becoming minimum. Angle of deviation is becoming minimum. Look at here, so for a particular value of angle of deviation, for particular value of angle of incidence, angle of deviation is going to be minimum. This particular value of angle of deviation only we can call it as a minimum angle of deviation. Minimum angle of deviation. So look at here. Once again, just let us observe this example. As we go on increasing the angle of incidence, children, initially angle of deviation also decreasing. It takes some minimum value. Further, it is increasing. Now for this, dear children, if we can plot a graph, here. So here, angle of incidence is taken on x-axis, whereas angle of deviation is taken on y-axis. Now as you go, initially when you are increasing the angle of incidence, what is happening? Angle of deviation is decreasing. So this is how. So it is decreasing. For a particular value of angle of incidence, deviation will become minimum. Let us say this is a point where it will become minimum. So let it be, it is a delta m, minimum angle of deviation. After that, again when you continue to increase the angle of incidence, what is happening here? Angle of deviation also increasing. So children, at this point only, at this minimum angle of deviation only, what will happen? Angle of incidence and angle of emergence are equal, and two angle of refractions inside the prism also equal. So children, this is how angle of deviation depends on the angle of incidence. So here we discussed four important points here, four very important points. What are those? Angle of prism, refractive index of the prism, and third one is what, children? Wavelength, and the fourth one is what here? Angle of incidence. So children, this is what actually how refraction takes place through a prism. Children, once again let us summarize whatever we discussed in this class. Let us just summarize that. So what happens when light passes through a prism? Gets deviated. It's very important. So children, as we derived expression mu is equal to sine of a plus delta m by 2 by sine a by 2. So to obtain that, we got these equations. The first one is very important. What is that here? A is equal to, we got r1 plus r2. That is, angle of the prism is equal to the sum of the angle of refractions. And the second one is, dear children, angle of incidence plus angle of emergence is equal to angle of deviation plus angle of the prism. And the third one, what we got? We got finally mu is equal to sine of delta m plus a by 2 by here sine of a by 2. And for thin prisms, for a very thin prisms, we got delta minimum is equal to a into, it is mu minus 1. And after that, we discuss the factors on which angle of deviation depends. So children, here angle of deviation is proportional to the angle of the prism, and the second factor is that angle of deviation is proportional to the refractive index, and third factor is that angle of deviation is inversely proportional to the wavelength. But what can you say about angle of incidence, children? Initially, when angle of incidence increases, deviation decreases. Further on increasing the angle of incidence, what happens? Angle of deviation also increases. So children, this is today's session. We discussed about what we can say refraction of light through a prism. So once again, what is the difference between? We know that when light passes through a prism and what we can say rectangular glass slab, refraction will take place. What makes the difference? The very important, the difference is that, the children, glass slab does not produce deviation. Rather, glass prism will produce a deviation when light passes through it. So this is today's lecture, children. In the next class, we will discuss very important point. Is what? Apparent depth, real depth, and how can we calculate the shift also. Children, we know that kingfisher, so how it can catch its prey? So simply it will be flying over the water pond or something, water resources, and it can catch the fish. But the thing is that how that kingfisher is able to see the fish in order to catch it? But whereas while the kingfisher is coming and catching the fish, dear children, what this fish is doing? It can escape, right? Why it cannot escape? What is the reason that? It is going to be so interesting lecture it is. That we'll discuss in the next class. Thank you so much. All the very best.